Rogue planets are the nomads of the galaxy. Unlike their star-bound counterparts, they endure perpetual darkness, untethered from the gravitational influence and illumination of a star. Free to travel the space between stars, trillions of them are scattered throughout the galaxy. Recent studies estimate that there are more rogue planets than those orbiting the hundreds of billions of stars in the Milky Way. This suggests that star-bound planets are in the minority, and the fact rogue planets even exist out there on their own suggests to scientists that they hold key insights into the chaotic and violent nature of planetary system formation. The idea of rogue planets was theorized by many astronomers during the 20th century, with the idea of rogue planets gaining significant traction in the 1980s and 1990s. It wasn't until as recently as 2012 when we had the first confirmation of one, with the discovery of the first rogue planet 100 light-years away. This free-floating planet, as rogues are officially called, is a Jupiter-sized planet that is 50 to 100 million years old, a relatively young age for a planet, and an age that gives us a distinct advantage in detecting it. As it drifted through the darkness of space away from the illuminating effects of a star, the residual heat from its recent formation was picked up by our ground-based telescopes in the infrared spectrum, an observation that unequivocally confirmed that this was a planet not orbiting a star, providing us with the first definitive evidence for the existence of a rogue planet. Subsequent detections of other rogue planets using similar methods have revealed more of these free-floating planets, with a trend towards young, massive Jupiter-sized planets dominating the rogue planet population, a finding that is at odds with our understanding of planetary formations. Planetary systems form with the collapse of interstellar molecular clouds that exist between the stars, and in some instances rogue planets form similarly to stars. As the molecular cloud collapses, a lack of substantive material will stop any growth into a fully fledged star, and a solitary Jupiter-sized planet will emerge in solitude, without a star, dooming the planet to wander the galaxy as a rogue planet. In other instances, where there is enough material in a molecular cloud, stars burst into life along with the planets that will form the planetary system. Chaos is prevalent during the early stages of planetary system formation, as planetary bodies violently jostle to become the dominant body along their orbital paths. Smaller bodies, unfortunate enough to get too close to the gravity well of a larger planet, will either be captured, destroyed, or have its own orbital path altered. In extreme cases, the smaller planet will be slingshot by the gravitationally dominant planet, not just onto another orbital path, but with enough velocity so that it escapes the gravitational embrace of their star. Travelling at tens to hundreds of kilometers per second, these smaller planets are sent on a trajectory out of their planetary system, never to return, leading to a nomadic existence as a rogue or free-floating planet hiding between the stars. Even the smallest planets leave telltale signs of their presence. When a planet passes in front of a distant star, its gravitational field bends the fabric of space-time, causing the light from the star to curve around it. This effect temporarily magnifies and brightens the star, a phenomenon known as microlensing, which indirectly alerts us to the presence of a rogue planet. The duration of the microlensing event also reveals information about the planet's mass. Larger planets produce longer events due to their stronger gravitational influence and greater bending of space-time. Microlensing events and the study of them have revealed in recent years that rogue planets might be 20 times more numerous than stars in our galaxy, with estimates placing their numbers in the trillions. And we are realizing an abundance of smaller, Earth-mass planets, rather than the larger gas giants, are more abundant in the galaxy. The prevalence of Earth-mass rogue planets implies that many smaller planets are ejected from their original star systems due to gravitational interactions and collisions, a finding that supports the idea that the early stages of planetary system development involve significant chaos and instability, resulting in planets being flung out into interstellar space. It may well be that out there is an early solar system planet that has been roaming the darkness between the stars for the last 4.5 billion years.